Till now we have seen DFA, NFA and finite automata with output, which are Moore machine and Mealy machines. And now let us see a special kind of finite automata, in fact is NFA. We are going to see special kind of NFA called Epsilon NFA. Okay, so the word is epsilon. Epsilon means empty string. So Epsilon NFA is different from ordinary NFA in the sense that if you look at any transition, that may even contain epsilon. So this is an example of Epsilon NFA. So this is actually looking like a DFA or NFA, and only difference is in DFA or NFA we don't have epsilon moves, right? So in order to define this Epsilon NFA, we can directly define it this way. Let us say Q, sigma, delta, Q naught and capital F. Q is set of states which we already know, and sigma is input which we already know, and delta is bit different here. Q naught is initial state and capital F is set of final states. So delta, if you remember in NFA, delta is nothing but Q cross sigma, which means if I am in some state, if I see some input, then I was going to 2 power q, power set of q, which means if I am in some state and if I see some input, I'll go to a power set of I'll go to a subset of all states. Only difference between Epsilon NFA and NFA is here I even have epsilon, which means on a particular state, on seeing some symbol I can go to some state, or on a particular state without seeing anything a transition is possible. See this, on A without seeing anything even we are going to transit some state, right? So it is also called as epsilon closure. So I'll talk about a property called epsilon closure. Now let us say epsilon closure of capital A. So epsilon closure of any state is nothing but what are all the states which you can reach only on seeing epsilon from A. Epsilon closure of A is nothing but what are all the states which you can reach from capital A only on seeing epsilon. In order to find it out, see this, always I can reach A on seeing epsilon. A can reach A on seeing epsilon. It is always there. So whatever is there in the epsilon closure, we are going to get that as the output. Therefore A can be reached, okay, and A can reach B on seeing an epsilon. Therefore B is reachable only on epsilons from A. Therefore epsilon closure of A is going to contain B, as well as B can reach D on seeing epsilon. Therefore epsilon closure of A is even going to contain ABD. This is epsilon closure. Fine. So now the question is, how can I convert epsilon NFA to NFA? Or you can even ask me a more natural question. We have seen one is DFA, other is NFA, and now we are seeing epsilon NFA. Now your question is, which one is powerful? We have already seen that DFA and NFA are equivalent in power. Why? Every DFA is nothing but NFA, therefore I can convert every DFA to NFA, and then I have even shown you a method using which NFA can be converted to DFA, right? Now in order to show that this one NFA and epsilon NFA are equivalent, see, by this definition, if you remove epsilon, it is nothing but NFA, right? Therefore you can say every epsilon NFA is NFA. So conversion from NFA to epsilon NFA is trivial. Why? Every NFA is epsilon NFA. Now if you can convert epsilon NFA to NFA, then we can say that these two are equivalent, and by extension all of them are equivalent. So now I want to take epsilon NFA and convert it to NFA. Let's see the method. Now I want to take epsilon NFA and convert it to NFA. Fine. So I'll go with the state transition table. State transition table is going to start with A. Now I'm not having epsilon moves, so I'll be writing only about 0 and 1. So first of all, in order to fill this particular entry, it is nothing but what does A, capital A on 0, where does it go? So you have to decide about capital A on 0 in the NFA. So in order to convert this DFA to NFA, I'll use this method. See this? Now I'll take state A. From state A, I have to see what happens on 0. So instead of seeing what happens on 0 directly, I'll see what is the epsilon closure of A, which means what are all the states that are reachable from A only on seeing epsilon, and then 0 and then epsilon. I'll write like this. It is nothing but, in order to find out this entry capital A on 0 in NFA, I have to find out capital A on epsilon closure, again apply 0 and again apply epsilon closure. Even you can think of it this way. So what has exactly happened is, I am going to find out epsilon closure of A, and then whatever I get in epsilon closure of A, I am going to find out what are their transitions on 0, and whatever is the result, I am going to again find out epsilon closure. This is the procedure. You have to apply epsilon closure on A, and then you have to apply on 0, and then again you have to apply epsilon closure on the final result. Instead of writing like this and then expanding, I'll just use this shortcut. So what is that I'm going to do is, capital A epsilon closure. What are all the states that are possible for A on epsilon? Only epsilons. One is A, other is B, and other is D. These are all the states where A can reach only seeing epsilons. On seeing one epsilon A, on seeing one epsilon B, on seeing two epsilons D. I should not even count them as 0 epsilons or 1 epsilon or 2 epsilon, because how many ever epsilons are there? 2 or 3, it is simply 1 epsilon, right? Now capital A on 0, where is it going? Capital A itself. Check this, capital A on 0 is going to capital A itself, and now capital B on 0 is going to capital C. Check this, capital B on 0 is going to capital C, and capital D on 0 is going to capital D itself. And again you have to find out epsilon closure. What is epsilon closure of A? Same, it can reach A, it can reach B, as well as it can reach D. What is epsilon closure of C? C will reach only C and not anything else. What is epsilon closure of D? D will reach only D. Therefore these are the states that should be present in this particular entry in the final NFA, right? What are the states? A, B, C, D. Therefore I am going to write it as A, B, C, D. Can I write these many states? Yes, obviously I could write, because it is NFA. Therefore any transition can be, contain any number of states, or it can even contain 5. Okay. Next I want to fill this row. What is this row? Capital A on 1. So again we are going to write the same way. Capital A if I have to find out on 1, I am going to write it as epsilon star 1 epsilon star. What is capital A on epsilon star? Capital A on epsilon star is, I can go to A, B as well as D. Only I am looking at epsilon. A, B and D. What is capital A on 1? Capital A on 1 is, it doesn't have any move, therefore it is 5. What is capital B on 1? Capital B on 1, it doesn't have any move, therefore it is 5. What is capital D on 1? Capital D on 1 is capital D itself. And what is epsilon star of D? D. So D is not going anywhere on epsilon except D. Therefore here I have to write D. Singleton set. Now what about B? In state B, I have to discuss about B on 0. Now I am in capital B and I have to discuss about 0. So I have to write epsilon star 0 epsilon star. Where does B go? Only on epsilons. It will either go to B directly or it will go to D. So it is going to B and D. Fine. And what about on 0? B on 0 is going to C, D on 0 is going to D itself. What is epsilon closure of C? Where is C going on epsilons? Only to C. What is epsilon closure of D? Where is D going on epsilons? Only D. Therefore I have to write CD here. What about B on 1? B on 1. This part is going to be same. Fine. Now what about capital B on 1? Capital B on 1, it doesn't have any move. What about capital D on 1? Capital D on 1 is going to have one move, which is capital D. What is epsilon closure of D? Simply D. Therefore, write it as D. What happens to phi? Phi is nothing but is not contain anything. So how can you say that it can go somewhere on nothing, from nothing, nowhere? So we are not going to write anything for that. Okay. Next one, C. C on 0. I'll be here epsilon star 0 epsilon. C on 0 is nothing but, C on epsilon star is nothing but epsilon, sorry, C, and C on 0 is, it doesn't have any move on 0. Check it. C doesn't have any move on 0, therefore it is 5, and therefore the outcome is 5. So what should I write here? C on 0 is 5. What about C on 1? C on 1. Find out C on epsilon star or epsilon closure of C. So C, epsilon closure is C itself. And what about C on 1? C on 1 is going to be, C on 1 is going to be. And what about epsilon closure of B? So it can even go to B as well as D. Therefore, I have to write it as B, D. What about D? Again, here discuss the same things. D, epsilon closure, find the epsilon closure of D and then find out the transition on 0 and again find the epsilon closure on D. Fine. So what is epsilon closure of D? From D I can reach only D on seeing epsilon. So I cannot reach anyone of any state other than that. And what about D on D? It is simply D. And what about epsilon closure of D? It is simply D. Therefore it is going to be D. Fine. And what about D on 1? So again find the epsilon closure of D and then find the transition on 1. So what is epsilon closure of D? Epsilon closure of D is simply D. And what is D on 1? D on 1 is simply D itself. And what about epsilon closure of D? Simply D. Therefore, this is again D. So this is the NFA for the given epsilon NFA. Now let's draw the transition diagram for the same thing. So how many states are there? We have only 4 states. So the main difference between conversion of NFA to DFA is, when I was converting NFA to DFA, the number of states, they have increased, right? And here when converting epsilon NFA to NFA, the number of states are not going to increase, number of states are going to be same. Fine. So let's start with this: capital A, capital B, capital C, capital D. So initial state is definitely A, that you know. Now the question is, what is the final state? So when we are converting epsilon NFA to NFA, the final states are going to increase. So whatever state that can reach the final state only on epsilon is going to be final state. Again, if I can reach the final state from some state by seeing only epsilons, these states are also going to be final states. So in this given example, in this given question, let me draw the NFA same like epsilon NFA. A, let me draw B here, and let me put C here, and let me put D here. Okay. So if some state can reach the final state only on seeing epsilon, then that state is going to be final state. So in this case, B can reach D only on seeing epsilon, therefore B is going to be a final state also. D is already a final state, now B is a final state. Now see this, capital A can reach capital D only on seeing epsilons, therefore capital A is also going to be final state. So remember this, number of states are same, that is the first one, number of states are same. And second point is, initial state is same, true. And the third point is, the number of final states may increase depending on, if a state is going to reach the final state only upon seeing epsilon, then even that state is considered as final state. Since B can reach D only upon seeing epsilon, you can even say B is the final state. And A can reach D only upon seeing epsilon, so you can say that A is also a final state. Therefore A and B are also final states. And all the remaining transitions you can take from this table. So see this, capital A on 0, what is it doing? On 0 it is going to be in capital A, as well as it is going to B, as well as it is going to C, as well as it is going to D NFA, right? Next, A on 1, where is it going? A on 1 is going to D. Fine. Next, B on 0, where is it going? B on 0 is going to C as well as D. B on 1, where is it going? It is going to 1, D. Next, C on 0, it has no move, and then C on 1. C on 1 is going to BD. C on 1 is going to, one is B, other is D. D on 0 is going to D, 1 is going to D itself, which means D is going to be 0, 1. So this is the NFA for the given epsilon NFA, right? So we shall revise what we have seen now. First of all, we are given a epsilon NFA. What is the main difference between NFA and epsilon NFA? Only difference is we have epsilon modes. If you look at the transition table, NFA is going to contain a Q cross sigma, which means from a state on seeing an input, I may go to many number of states or no state or one state. That is true. But then if you look at epsilon NFA, I can even be from some state and then looking at nothing, which means epsilon, I can go to any number of states. So only difference is epsilon is added. So once you have found out this, now we have to construct the state transition table. So in order to construct the state transition table, we need a property called epsilon closure. What is epsilon closure? Epsilon closure is nothing but set of all states which can be reached from some state is going to be epsilon closure of that state. If I say epsilon closure of A, it is nothing but set of all states reachable from A. Then if I have to fill some row, fill some entry, then you have to write like this. If I have to fill capital A on 0, I have to write epsilon closure, which is nothing but I have to find epsilon closure of A first, and then whatever I get, I have to find transition on 0, and then whatever I get, I have to find epsilon closure again. So this is the final. So whatever I get here, I am going to write here, right? So this is how you have to construct the NFA.